Okay, we are going to figure out this carbon cycle together, and I'll show you what you need to do, and hopefully this will be good for you to complete the whole thing. So we've got our directions here, and it tells us what we need to do for step 1. It says run the simulation to 2110 to 110 with the default settings, and use your data table to record the total carbon levels in the sink, which is terrestrial plants, soil, oil, gas, coal, surface ocean, and deep ocean. Using that data, we're going to answer some questions. Okay, so let's pull up the worksheet and let's start the simulator. So the simulator is set at 2010 right now. And we're going to use these default settings, and we're going to look at these little things over here, and we're going to pull up our paper. This is what your worksheet looks like. Step 1. So we're just going to fill it in. We know we're set at 2010 right when we start. The atmosphere is at 720, and 391 parts per million of it is carbon dioxide. So we're going to record that. I forgot which one we record. So I'm just going to go with 720. Oh, shoot, I need a pen. Whoop. 720. The ocean surface is at 1,000. The deep ocean is at 38,000. The oil and gas is at 500. The coal is at 3,500. And the soil is at 1,800. And the plants are 700. Okay, and then our directions say to forward it all the way to 2060. So let's do that. So here's 2010. And then we're going to run it to 2020, 20, 30, 40, 50, 60. Let's hover over here. We're at 2060. And the atmosphere is at 569 parts per million of carbon dioxide. Okay, but the amount of carbon total is 1031. 1031. And the ocean surface is at 1,000. And it has this plus of 107, so we need to add that together. So it's 1107, and the deep ocean is 38,250 because of that plus 250 down there, right here. Okay, oil and gas is now at 66 because we burned it for fossil fuel use. The coal also has reduced 3170, and the soil added 238, so we got to do some math. 1,800 plus 238 is 2038. And the terrestrial plants are now 758. Okay, now we're going to forward this to the year 2110. Boop, boop. Let's see, where am I at? 28, 90, oh, oh, highlight that, 2010. And now write down these numbers. So now we're at 2010. Our atmosphere number is now 2254. And look at all the atmosphere, all the carbon up here in the atmosphere. The ocean surface is now 1333. We're just adding those two numbers together. The deep ocean is 39091. I'm just adding these two numbers together, the 38,000 and the 1,091. The oil and gas is now 0. We sucked it all out and burnt it all. Bad humans. Coal is really reduced, 700 left. And then soil is 1,800 plus 341 is 2141. And the plants are at 899. So that's the data for part 1, lesson 1, step 1. And now you have data to answer the questions. I'll put this over here for a second. And you can answer all these questions. So if you only had half the flora in 2010, which would be 350 instead of 700, how would it be different? How would you change the simulation to show that? You don't have to change the simulation, just say how you would change it. And then this number 2, what's the relationship between the increased carbon in the ocean and the soil? So let's look at our data. Look at ocean increase right here. What's the relationship between this increase and this increase? What's going on? And so the questions for here is saying, how else might carbon get to the soil? So think of the carbon cycle, and how else could carbon go from ocean to soil? What else might happen? Okay, and then 3, using this data that you generated, what's the relationship between the percent increase in fossil fuel consumption and the increase in atmospheric carbon? So let's remember how to do that. So to do percent change, that means change, in case you didn't know that. It's the final. Oh wow, that's not how you spell final, Miss Ellie. So it's the final value minus the initial value. Initial, it's hard to write with my pen. Divided by initial times 100 to get your percent. So if we first look at, I forgot what it was already. Let me look. We want to look at fossil fuels and atmospheric carbon. Okay, so our fossil fuel percent change, this is going to be easy math because there's a 0 involved. Oh wait, fossil fuels, we need both of them. Trick. So let's do that one first. So percent change for fossil fuels, I like to label what I'm doing, is going to be equal to the final value, which is down here, 700 plus 0, so 700, subtracted from the starting value, which are these, both of these, so 500 plus 3,500 is 4,000, divided by the initial value, which is 4,000. And if we put that in our calculator, which I totally have, we get 700 minus 4,000 equals, divided by 4,000 times 100. I get minus 82.5, which means I lost 82.5% of fossil fuels out of that system. And then the other one it asked us to compare it to was atmospheric carbon. So now let's calculate atmospheric carbon percent change for atmospheric carbon, and that is right here. So our final value is 2250, subtracted by our initial value, which was 7, wow, that's bad writing. What was that number? 720? I hope. I guess I can check real quick. If I reset this, I can make sure that's what it was. Reset. Run it a decade. Oh wait, reset. Yeah, 720. Okay. Okay, so 2250 minus 720 divided by 720, because that's the initial value. Put that in your handy dandy calculator. 2250 minus 720 equals, divided by 720, and I get, oh, times 100. I screwed up. It's okay, I can do it. Times 100. 2250 minus 720 divided by 720 times 100. 212.5% increase. 212.5%. So this is a decrease because of the negative sign, and this is an increase because of the positive sign here. Okay, so we've done our calculations, and now, oops, is there some sort of relationship going on here? This went down by 82%, and this went up by 212%. So we need to think to ourselves, is there a relationship there? Just off the top of my head, if I divide those two numbers, it's 2.5 times the amount. So maybe that's a relationship. Okay, so something to think about there. So that's how you would do lesson 1, step 1. And then the next part, lesson 2, lesson 1, step 2, blah, blah. So now we're going to go step by step and record all of those amounts and see where the carbon's really going 1 decade at a time. Okay, so let's go back to our simulation. We're going to start that again, and this time, whoops, we're going to look at all of this. So we're going to look at the smokestack, the atmosphere, all of the things. We're going to fill them in step by step. So we're going to reset this, start over, and here's our baseline for 2010. We're going to fill that in. So the smokestack right here has nothing, so that's a 0. The atmosphere started at 720. The ocean was 1,000 surface. Deep ocean was 38,000. Oil and gas 500. Coal 3,500. Soil 1,800. Plants 700. So we just copy basically what was up on the first one. Now we're going to go step by step. So the next decade, which is 2020, now we're going to fill that into our graph. So smokestack now has 99. The atmosphere is now 753. Ocean surface is 1035. Remember, we're just going to add this together. The deep ocean is 38021. Oil and gas is 444. Coal 3457. 3457. And soil is 1800 plus 202, so that's 2002. And the plants are 708. So I'm just gonna keep making this go forward. Decade, run a decade, go back, put the new numbers in until this form is totally filled out. So I'll get all these numbers filled in, and then I'm just going to answer those questions. So it's the same thing over and over and over. And then when we get to the questions 2, it's going to ask some relationships. What's the relationship between the increase of total carbon? So just look at your data table, and that'll help you figure it out. So I'm guessing the hardest thing for y'all to do today was doing that percent change calculation. So we did that together. Hopefully that's helpful. And this one, you just fill it out, look at the data table, and answer the questions accordingly. There's not calculating on the next part. And then lesson 2 is just kind of more of the same. Change the settings, record what you found out, and then just answer the questions. So hopefully that helps. If you get stuck, you can send me messages on Remind, and I will be happy to help out with anything you have. And if we're still stuck, we'll talk about it a little bit on Monday, but hopefully that's enough for you to get going.